What up, Linux gang? Yeah, how's it going? Good morning. Hey, Alexandra, good to see you in chat. Let me get all my stuff together. I'm not on Wi-Fi, that's good. Yeah, so cool. Got stuff going on. I have at least some discussion stuff to talk about. Cool. I am streaming. Stuff is visible. We have a lovely set of 4 collaborators now, so it's not just my face, or even like a lack of not even my face. I moved the camera up a little bit, and now I'm hanging out in the bottom of the frame. Let me move that back. I'm like super cropped in on OBS, and I super cropped it in for where the camera was. Okay, cool. So we've had some pull requests. Let's look at the ones that got merged. Firecracks added deformat format on some stuff, which is excellent. It makes gets rid of some big ugly match statements that were there because I was too lazy to add derive for it. So that is lovely. That's on the netstack send error and maybe the interface send error as well. Love to see it. Alexandra added a README for USB demos. This is after we had our stream yesterday, illegal Tuesday stream, and some Nix stuff. So if there are other Nix folks out in the audience, hell yeah, you have a bit of a cozy setup thanks to Alexandra. And we had Numinex added some. So this got mentioned in another, I think maybe Monday night stream of. The stud feature is actually more Tokyo stud flavored because I'm using Tokyo's TCP sockets and stuff like that. But to make it clear that we're not like super hard coded to Tokyo, it just happens to be the only impl we have right now for stud. We renamed that to Tokyo stud for the feature. So I'm excited to see all that. There's also been some good discussions. I keep just shoving stuff here. Let me actually check. See if anyone's responded. Is there some other conversation? No, not yet. Cool. Let's see what's new. I'll just go over all these because I don't think I've talked about any of them. This was Numinex's comment about that, so that one's resolved. Someone was asking if we could have a fully blocking use case. Not everyone loves async. Ergot itself could probably be made blocking. It might require custom sockets. I'm not sure. Because you'd want it right now. It like because actually dispatching a packet is always blocking. It's just how it notifies people that like a socket or whatever that things are ready. So right now it uses. Excuse me. My talk async wait queues for all of that, so you get like an async notification. You totally could make one that used convars for everything, and so that way you could just do like a blocking receive with threads and stuff. I think it'd definitely be possible. I'm probably not going to do it, but I definitely think it could be possible if people were interested in it. If someone wants an easy PR, I have... Well, maybe not easy, because these diagrams exist in MonoDraw, which is checked into the repo, but I don't expect most people to be on macOS and have MonoDraw. So actually, maybe not. Maybe that's not an easy one. Zach was asking about using Bluetooth Low Energy for this. So I haven't done a lot of Bluetooth Low Energy. Sam came along and gave some explanation of how you might be able to do it. One thing is that the BLE is limited to an MTU of 185. So one way that you could handle that is by doing a stream sort of thing, sort of like UART over BLE works with the Nordic UART service. That's essentially like breaking up a stream of data into frames. Another option would be, and I should write this out, but fragmentation right now is sort of I don't handle in the net stack. So you could do reassembly where you could say like this is frame 1 of 5 or whatever, and then reassemble the frames. I have some code for that if someone's interested in that. I have some code for that for something else, especially if you limit it to a very simple, like, you know, if we lose any of the fragments, we lose the entire frame kind of thing. This could also be an area where having reliable channels would be more interesting, or even having reliable interfaces where the interface will store messages and not just kind of blind fire them. So that's one thing. Another thing that came up is how discoverability works, and these are things that I have open issues for, but I don't have a perfect answer for this yet. Someone's... Oh, cool. So there's a couple different ways we could do discovery. In Postcard RPC, discovery worked because we had a giant macro where you declared all the types and all the endpoints that you had, because all the endpoints were forever, and we would just allow you to send that out. Like basically someone could request, it's called a schema report, and it would just give you all of the information about all of the services. This is a little more challenging to do in Ergot because everything's kind of, like when you're sending, you don't have something permanent sending, you just send packets. Although for discovery, you probably only care about like receiving sockets. So the answer would be we probably need some way to, for either the net stack or a service that's running on the net stack, to accept incoming requests that are like, tell me about yourself, and then go through and say, well, I have these sockets open and they have this name and they accept these kinds of packets, and then send that back on request, or just every now and then share some fun facts about yourself. So this would be like adding some kind of out-of-the-box service that, like, let's say every 10 seconds, 60 seconds sends like a listing of everything, or have the ability to have like a broadcast message that's like, hey, everyone, either tell me about yourself, or hey, I'm looking for a service like this. Does anyone have this service? Tell this person. So I have some open issues for that. So like, I think the name server one talks about this. So this is one to look at of how to possibly do it. I also have some other stuff for service discovery. The answer is, and I'll write this up for Zach, but the answer is you can't right now. There's not really much. I have a lot of ideas for it, and this is a good thing where I either can make something very silly and people can decide to use that or not, or this would be, if someone's interested in doing this, let me know. There is some information that the sockets themselves have, so let me... docs Ergot. It might actually be an Ergot base. Ergot base. So in sockets, there is a socket header, and this is essentially what all sockets have. Oh, I think this is wrong. I need to update this. But they exist in a linked list. Each socket has a vtable. Vtable right now is only concerned with things like receiving messages. We could have like a tell me about yourself message or something like that. They have the key, which is basically the kind of message that they accept. They have a name hash, which is a hash of their name. So it's a 32-bit hash of a name. They have some attributes, which are whether they're discoverable or not, which is basically if they participate in service discovery, and then what kind of message they expect. So is this like an endpoint request? Is it a topic subscription? And then their port. So this is all things that the net stack could be able to get. If we need the socket to do something fancier, we could add a socket vtable method for this. But first, we got to kind of figure out what this should look like. Whether it's like you do something ARP style, like, hey, who has this? Tell me. Or whether all of the net stack like broadcasts some of this information automatically, and then people listen and build up their own local database about it if they care about it, or some combination of those two. Yeah, and then we probably almost need like a who's on the network, tell me kind of thing, like a device discovery kind of thing, because right now some devices only work after you start talking to them, and so I just kind of blindly ping a lot of devices in a lot of places. So this is an area where there are many right decisions and no like one exact answer, but if someone wants to help come up with an idea for this, open up a discussion for it, and we can make something. And if it doesn't work perfect, great, we'll make a better thing later. But this is an area where definitely help could be wanted, or just tell me exactly what would be useful for you and I'll build something. And we're not too worried about stability right now, so we could build something and then go from there. A shower thought the other day, maybe it's simpler to focus on two separate type networks, basically static network where there isn't a seed router and all the IDs are hard-coded. The use case would basically be a finite network on embedded things. And the more traditional network where there's a proper stood end which works as a seed router, which can then be proper dynamic where people can come and go. If we have a seed router, wouldn't it be smart to just have that one maintained table of this is what's on the network and this is X service? Yes, I definitely. Okay, so should we have hard-coded networks? I don't know. I like the idea of basically not hard-coding that and to make it so that there's at least a simple option for discovery. This is sort of what AppleTalk does, both to its benefit and its detriment a little bit. AppleTalk networks were known for being a little chatty, so they would spend a lot of time sending messages and processing messages that were just like, hey, I'm here, I have this stuff, let me know what you think about that. But it meant that you didn't need like a dedicated router or anything like that. So I'm not against the idea of having hard-coded networks, but I feel like I don't love it. Like, I'd prefer to just like have networking and it just works, but I don't know. That's a balance that I want to figure out, but I'm not against it. The other thought is to have a seed router that is all-knowing, and I think that's a very reasonable way to do it. I've thought about having like a more formal seed router where it handles, because it's already handling the assignment of network segments, to also have it maintain a table of all of the devices. But then the question comes up of what happens if you have, for example, a USB device that, like let's say you had a device that had two microcontrollers on it, one with USB and one that's connected over serial. We still want those two to talk to each other when they're not plugged in over USB, but when they are plugged in over USB, we want them to keep working. So the answer is I don't know. Again, this is another one of those areas where we should probably just do something. This is where I'd love to be motivated by someone's concrete needs for a project, and we'll build out from there. Because otherwise there's so much analysis paralysis going on there. But yeah, those are my thoughts on that for now. So the answer is, how do we do discovery? Right now we don't. There's some stuff where we don't quite have discovery, but for things like if you know a device is there, you can send messages to the the any port, which is 0, and we can see if messages make it there, but that doesn't help you with what devices are on the network. So I think there is a gap there, and maybe this would be a good place to I might break this out into a separate discussion for like what kind of discovery do we want to do, and then I'd love feedback on it. Okay, so we also had a question from, I'm going to pronounce this wrong, I'd love to know the right way to pronounce it, but Haubogu maybe, but the person with the wonderful cat avatar. Looks like maybe your English name is Jason, so I might go with Jason for right now. Apologies if that's not what you want. But they're asking, I found the eUSB demo a little bit complex, and I'm having trouble understanding it, and there's some questions I have. Our run RX, let me pull that up just so we can look at that side by side. Let me close this. Okay, so let's run down this. So Are the run RX and run TX like the background task like USB device run? Yes. They are the worker tasks that are... so the USB task is the actual like USB driver, like handling incoming USB frames and things like that. This is like the embassy USB task working. Run RX is the RX worker. So this is basically when packets come in over USB. This is the task that is processing them and then submitting them over to the net stack. So USB frames can, at least this is on the 52840, so it only does USB full speed, which means USB frames can be up to 64 bytes. But Ergot frames could be larger than that. You could send a 128 or a 256 byte packet. So the job of this task is actually to, we can jump and look at that in a second, but it like takes the raw USB frames, assembles them into Ergot frames, and then deserializes them and passes them into the net stack and says, hey, I got this frame. So its job is to do that. So that's our receiver task. The transmit task, similarly, when the net stack gets something sent and it says, oh, this goes out the USB interface, it serializes that and shoves it in an outgoing FIFO. And this TX worker is basically listening to the incoming data from the net stack and shoving it out over USB. So these two are basically like turning USB data into Ergot frames and then turning Ergot frames into USB data. And then the USB task is the one that actually runs in the background and does that I/O stuff. There are many tasks: ping server, yeeter, press listener, LED server, button worker. I don't really understand which one I should use for a simple PC request MCU pattern. That's a good question. These demos I used for just like as I was developing features, just seeing how they worked. I'd say the LED server is probably the most is the one that you want for what you're describing. This is very much like Postcard RPC endpoints. So we can see what this server does is it opens up a bounded endpoint server. So it accepts requests of the LED endpoint type, and it will accept, like, it has a queue of up to 4 of them. So, it'll process them as they get them, and it says that it has some name. And this one I actually have a pool size of 4, so I think there are 4 LEDs on the NRF52840DK. So I think I have them as like LED 1, 2, 3, 4 or something like that. Yeah, LED 1, 2, 3, 4. So I start 4 servers. And this one is listening to requests. So when it gets delivered a request, I think on is the name of it. This is a service that takes a bool and returns nothing. We can see the definition here. So it's an endpoint where the request is bool and it returns nothing. So what you do is you serve, and this will wait until we get that incoming request. We get the request as a closure, and then here we set that LED to on or off, basically. And then normally this serve function returns the response, but because the response is an empty tuple type, we just return nothing, and this actually automatically sends back the request. So this is basically the simplest endpoint here, which is like that request response pair that you'd expect from Postcard RPC. So I think this is the I can explain the other ones. Press listener is this one is just subscribing to a published topic. I think this is just I added support for topics, so this one's just listening and printing over deformat all the messages that it sees. This button worker is waiting for the button to be low. So we're waiting for the button to be pressed. When the button is pressed, we send a request to the LED endpoints, the one we looked at before, that sets it to be on. And then we also broadcast that a button has been pressed. And then we wait for the button to be high, so we wait for it to be released. and then we turn the LED off. So this is like a very complicated way of just saying, like, whenever the button is pressed, turn the LED on, and whenever the button's not pressed, turn the LED off. But it's using like message passing in between the local device, and like it's really talking to itself kind of here. But even if you didn't press a button, you could from the computer command the LEDs to be on or off, because basically the server is going to accept connections from either local or remote on this. So that's I should probably make a simpler one. I should make this is like one of those, I was just using this for testing things as I was building stuff out. So it's maybe a little bit much. I'd be interested in making a simpler one. I use USB for other purposes too. So I have to use storage init without build. This function seems lacking some initialization code. Yeah, it's possible. I copied and pasted a lot of this from Postcard IPC, which has a similar setup. It's possible I didn't copy everything over. So if you want to open up a PR that fixes this, that would be cool. Yeah, this is just me missing that. So let me know. I'm happy to take a PR for this. How can I request from a PC? So, yeah, actually, I'm going to point you towards a different demo because I have a newer demo and I should talk about this. This tilt sensor that I have, this is the one that I've done on stream a couple times, but I've added some stuff to it. So it has the PWM channels now. And I have a PWM server. So it starts one for each of my LEDs, which are like PWM channels. And it's also doing a server, and it's taking incoming items. It clamps the value between 0 and 1.0. It turns these into PWM values, and then it sets them, and it sends back what time it actually did that setting. So this example is showing that same kind of server role. But then if we go back up to demos, I talk about here and having all the pieces there, but the Tilt app is the PC side of that. Oh, this isn't super useful. So here we can see in our loop, I have a loop where I'm basically listening to incoming accelerometer data, and then every 5 milliseconds I do some math on that, and then I send a request. So this is that rec-resp. So I send it to the destination. This is, again, me sort of cheating and knowing what the address is going to be. And I send it the value, which is an F32, and then to the name. Alexandra's going on vacation. Hell yeah, have a good vacation. I'll be here for the next couple weeks, so I will see you when you get back. Hopefully you have some time to recharge. So on the desktop, yeah, this is me sending the request on the desktop. So it's doing this rec-resp, which is what is used for endpoints. So it takes an endpoint, you give it the request, and it gives back a response. Here, I'm just kind of ignoring it, including even if it times out and stuff. So, yeah, I could probably shine this example up better as well. Yes. So I'm going to point you towards the 2350 as a more complete example, and I also still owe some better comments here. For a single endpoint, for example, Echo Server, I have to spawn at least 4 tasks. USB, TX, RX, Echo Server, am I right? Because I have generics on everything, I have to use join select for this, which increases the executor's workload when there are many tasks joined. Is this the simplest version of an Echo Server? Maybe. I don't understand why you need to use... You should... I know that you can have types... Okay, so the answer is Embassy, when you spawn a task, you can't have generics on there. However, you can, for example, in a specific application, you can have type aliases for that. So, I mean, for example, my worker task, let me find something that takes something. So, I mean, for example, the USB device here. The USB device has a generic parameter, but I define that here. Basically, like, I fill in the generics. So, like, it has generics, but you can fill them in, particularly for applications. This ends up not being so much of a problem. Yes, you're right. You could do something like this, but you might not have to. We could also combine these into some other way. But I think, to be honest, I don't think you need to do it in one big select. If you want to catch me in chat somewhere, let me know. I'm happy to take a look at your code and see if there's a simpler way to do this, but I'm pretty sure you're fine for this. And then the last question is how to add the context of the message processing. Is there an example? I'm not sure if I follow what you mean. The idea is that you have a socket and your task is generally going to have whatever context you have. So for example, here in this PWM server, my context that I have is this PWM channel. So you can do that with serving that data. If you need more shared context, you could have like a shared mutex or something like that. And inside the serve function, so serve blocking just takes a non-async closure. There's also serve, which takes an async closure. So for example, if you had an async mutex that you pass to your tasks, you could just lock that, get the context, and then use that for serving the response. But yeah, so I mean, the answer is you would keep state however you keep your state. I don't pass it to you in the handler. I expect that you have sort of like you can just pass that in to the closures, like the async closure or things like that. So, you can just have, I mean, if it's something owned, like this PWM item that I have, you can just use it in this loop. But yeah, if you needed like a more complex, like what is my configuration, you could pass that in as a shared static. Like you could put that in a mutex in a static cell and then just pass out shared references to all of your tasks or your handling functions and stuff like that. I appreciate you trying it. It's definitely not dumb. My docs are very, very lacking. And if you have a question, I've seen you around. You're definitely not dumb. So I would love to get these docs improved. If you want to open up any PRs, otherwise I'll go back over these. I'll link you to this stream so you can listen to me. Otherwise, I will try and write these up and open issues and improve the docs for this. So I definitely think it needs to be better. So I appreciate you trying. Thank you for bumping into this. I had someone ask about how I plan to use Ergot for Namas. So Namas is my operating system project that I work on with some other folks. Most of them, I mean, that's why we're using the Namas Matrix channel to talk about Ergot, is because I eventually want to use Ergot as sort of the backbone, like the actual, think of what I want for Namas, like it's like doing networking over IOU ring on Linux, but instead it's using Ergot as the networking between the kernel and the user space or user space and user space. And instead of IOU ring, it's like a ring buffer kind of thing. So the idea is that if you want to ask the kernel for something, you send an Ergot request to it, and you eventually get back an Ergot response. And then you could do service discovery to find other processes that are running on the same device. And then if they're willing to accept incoming requests, you could send them requests. So you could do like inter-process communication the same way that you would do like inter-device communication with Ergot. And then eventually, when you have multiple devices, like let's say on a circuit board, you have like a keyboard controller, a display controller, a network controller, and a main processor. You can just communicate with all of them because essentially you join them as a network. And the idea is sort of model the kernel and user space connections as like they were a network connection, like a serial port almost. But yeah, that's the idea there. But this is like far future ideas. And then Jonas had a question about his project K23, which looks interesting, like a WASM microcontroller operating system. Seems interesting. If there's a fit for Ergot in there, hell yeah. If you want to do something similar to what I'm doing for Namas, hell yeah. Let me know if you want to chat sometime, Jonas. And then we got this one just now. I don't know if this person is... Yes, it is sounding very Erlang-y. That is very much the model that I'm going for, is that instead of having PIDs and like a process or whatever. I mean, it is the same kind of thing, is that you have a socket. In Erlang, every process is a socket basically, or it's like a PID is an address kind of thing. But yes, it's very Erlang-y. Like, I want to basically turn a motherboard into a cluster of services, if that makes sense. So basically acknowledging that we have a distributed systems problem and using actual networking and distributed systems for that. And like, my go-to example is, I have this device that I love and I want to spend more time on. This is the Clockwork Pi PicoCalc, and it has a main processor which is a Pico. It's like a Pico footprint. So right now it's a 2040. I'm going to put a 2350 in there. But it's got a microcontroller that runs the keyboard. And eventually I want to put an ESP32 Wi-Fi chip in there as well to do Wi-Fi. And then I basically have 3 microcontrollers in one box. And it's literally like the meme of like 3 gremlins in a trench coat kind of thing. But the goal is to get them to act together in a way that is reasonable. And when you connect to it over Wi-Fi or over USB or whatever, that you could talk to any of those 3 devices if you wanted to, and if the system lets you. Eventually I'll need things like firewalls and stuff like that, and ACLs and off stuff like that. But it's very much like, I'm trying to figure out how to do Erlang for embedded systems kind of thing, because we've gotten to the point where a lot of embedded systems have multiple 32-bit processors on them, and it's kind of silly not to treat them like computers. I would very much welcome a documentation section for the overhead that Ergot introduces versus, for example, using raw TCP UDP frames. We use several devices that stream data, and throughput is of utmost importance to us, and a clear explanation in the docs would help us evaluate the adoption of it versus, for example, using our own code and having messages that are simply a C array with a message type, byte, and packet length. Yeah, I think I have that a little bit in the docs these days. Give me 1 second. Book. I think I talk about, so I mean, like, frames talks about what I have in each message. There's the common frame header, which has source and destination address, a sequence number, which is a U16, a frame kind, which is a U8, and a TTL, which is a U8. Some frames, like if you use the discovery item, they have a key, which is an 8-byte item, and a name hash, which is a 32-bit value. Sockets can have a socket header. So the answer is, the minimum frame overhead is something like, because all these are varants, which make it, the answer is it depends. So like this, the smallest this could be is 1 byte, 1 byte, 1 byte, 1 byte, 1 byte, so like 5 bytes. But practically it'll never be that if you're not like only talking on localhost. So I mean, like 10, 15 bytes. The question is how you do your communication. So for example, if you are already using if you already have a TCP IP stack, you can do Ergot over TCP, like over TCP or UDP. I only have a TCP impl right now, but and then it would be adding overhead because it would be encapsulated inside of that. If you have a different transport, for example, if you have a serial port, then you might not have any TCP overhead that you're adding onto it. It would just be like, this is enough to get you all you need basically over a serial port. You might want CRCs, or you might want like COBS encoding if you have no way of doing framing. But the answer is it's going to add a couple bytes. The serialization format for messages is postcard. Postcard is fairly well documented on exactly how large the data types are. In a lot of cases, because it uses varants for numbers, messages end up being smaller than just like mem copying a C struct. but there's some encoding and decoding time and things like that. But yeah, the answer is, the hope is that Ergot never introduces enough overhead for it to be noticeable. Where if you really are noticing the last couple bytes of overhead, then you're doing something fairly, very high throughput. But the answer is probably maybe like a dozen bytes, maybe less. Depends on how you chop up your frames and things like that. Yeah, I'd be happy to talk more concretely. The answer, part of the reason why I haven't documented this super firmly so far is because I do still expect some breaking changes. Like I'm figuring out if we could get rid of, for example, sequence numbers, or whether they're necessary to have, or whether we want to mandate having a CRC 16, for example. So today the answer is approximately between 5 and 10 bytes of overhead for messages, and then your data is encoded in postcard. But yeah, I'd be happy to help evaluate that if you have a more specific example, but it's still a little bit in flux. So yeah, eventually I need to come back. I'll come back and give a written answer to this, and I'll probably link to the live stream on this. Maybe I'll end up putting chapters on here so that I can link people to them. But yeah, hopefully that was useful. I don't know if anyone else has questions in the chat. If they do, now would be a good time to ask. Otherwise, what am I going to work on today? I might go through here. I might document some of the examples a little bit better. I'm going to spend some time responding to these questions. I appreciate people throwing questions my way, and I'm happy to keep chatting. Yeah. I'll probably open a discussion for discovery so people can chat about that. Yeah. I don't think I have anything else. So thank you to the folks in chat. Thank you to the folks who are watching. Thank you for the folks who are watching this later. But I'll probably go off now and write some more. And then, yeah, maybe write up some stuff for Discovery, and maybe come up with a very bad version of Discovery. Because, yeah, I've been trying to egg people into saying, well, I need this, and then either getting them to do it or to get them to shake out exactly what they want, so I could kind of break my analysis paralysis on this. So, yeah, excited to do so. Thank you to folks for watching, and I'll probably wrap up now. I will be jumping on at 8 o'clock today. So today is Wednesday, so it's not an illegal day, so I will wrap my day up at the end of the day. But until then, I will see you all later.